Today's video is going to be about quantum mechanics, and we will be doing something different from for today. Instead of talking about a topic, we will try to solve the equation. We'll try to solve. Okay, we'll be solving uh, like maybe only two problems because in quantum mechanics one problem is of like one page. So problem one, okay, is that but before talking about the problem, the equations we will be using today are the famous equations which are used to define the potential well. Okay, so as a summary or as a super overview, we know that this is over here a potential well, and in this potential well, in these ranges, region 1, region 2, and region 3. In these regions, in these regions, velocity, sorry, potential difference equals to 0. But in between, potential difference is more than the energy. Okay, of the whatever you think of it. So what we are trying to see or do here is we can solve the equations for this potential well, and we get two equations. Okay, since this all the topic is the video is about solving the problems down here, we will not actually derive the equations, so I'll just give the equations. The equations are psi is equals to square root of 2 over L is this range. Since it's between 0 and L, so it will we will look at L, the L sine n theta h, or n theta, not theta, that's pi, and L. Okay, and so x over L, and bracket. The second equation is, and it's my favorite one, like one of my favorite ones, which is energy expected energy, which is which is n square is n square h square over 8 m l square. Yeah. So here let me define what n actually here is. The n is the state of the particle, state of particle. Okay, meaning n refers to as, well, for me, for now, just erase this. N refers to as, if these are the energy levels, let's suppose if this is energy level 1, 2, 3, 4. Okay, so if we have a question, let's suppose n equal to 2. So we're talking about particle going from here. Let's assume n equal 1 is, assume n1 equal ground state. Okay, so n equal 2 means we are talking about the particle going from ground state to this state. Okay, n2. So actually n2 refers to as the excited state. This is what we call when a particle goes from its ground state to any other state other than the ground state. It's known as the excited state, no matter which number or which what do you call this line it is in. Okay. uh, okay, so then if we have an equation that um, how do I say this, uh, if we have an equation, so again over here, and other than that, is there any other unknown value which I didn't explain? The size there, sine. So uh, till here is enough for the overview. Now we go for the problems. Okay, problems. And so the problems are, number one problem is here. I Since I don't have the question, I'll just read it out over here. The question is that we have to, first of all, the question is all about expected value, expected energy value, expected or not expected. Could we say it expected value? Let's suppose energy. We're not talking about expected or not. Let's suppose we want to know the energy outcome, and expected here will take an average value. I'll say expected is average value. Okay, so the question is the state of a particle of mass m, mass, let's make this mass unique. Okay, okay, now in a one dimensional rigid box. So important here is that even this equation over here, these two equations are one dimensional. How? We're talking about particle which is in this potential box, which is in this potential well, which is moving either in this x-axis or in the negative x-axis. X-axis positive, x-axis negative. So it's either moving left or right. That's one dimensional. Then in the interval 0, so again let me make the box 0 and 1 in a rigid box. Let's suppose we put this, we make a replica of this particle. Let's make a replica, and this particle goes here, and now it's moving in this, either in this section or this section, with L positive and L negative. Okay, now um, so the normalization wave function of the particle is given as, it's given actually, root of L and 3 over 5 sine 2 pi x over L plus 4 over 5 sine pi x n over L. Doesn't matter how I write it, as it will give me the same answer still. So this is our x. I'm sorry, pardon. So um, here is our normalization wave function, and so now we'll be finding the expected outcome, energy outcome, and average value of the energy outcome of these both. So when we talk about the equation, this equation over here, uh, this equation over here, actually these two equations are considered to be one, as they have some similarities. Okay, so by what I mean by similarity is that over here in this, in this part of the equation. Wait, let me just, if it's possible, let me just take out this equation from here. This part of the equation over here. Copy and wait and paste. Okay, so what I want to show is, we know that this n over here, this n over here, it's common in this one as well as it's in this one. Okay, it's common in both. So what I mean to say is that if we, if n over here, n over here refers to the number, the excited number, that means this number and this excited number, they should be the same, right? So if they both are same, that means the two, since it's plus is in the middle, since there's a plus in the middle, that means we have two excited states, and these two excited states are state number 2 and state number 4. So in terms of level, I will say 1 2 3 4 5, and this goes from 0 1 2 3 4. And so since I add 0 here to fix myself, this is the ground state. Okay, and from here it goes to state 2 and state 4 directly. So it's going to two states. Now what, what do we do? So since we know that n is equals to, n is equals to 2 and n is equals to 4, we write E of, since our goal here is literally to find energy measured or the possible outcomes. Okay, so since there are two possible outcomes as we know the energy values, so here the first equation, the first one will be, first let me write the general equation. Now the first equation will be 2 square h bar, so in sub bar, 8 ml square, and the second one is, so if we simplify this, we get 4 h bar, h over square over m 8 ml square. This refers to as, 4 and 8 is, so it becomes h square over 8 m, or not 8, it's 2 ml square. So this is our first expected value. In quantum mechanics, most of the question answers are given like this. Answer, most answer are like this. Okay, now the second one over here is the same, we just have to make one change, and even now I think you're able to understand what I'm trying to do. So on the only change is the number we use, of course. So it will be, this changes to, I'll just straight up write the answer, 2h square, sorry, 2h square over 8ml square. Okay, so this is our second equation, so the second answer. So the two possible outcomes of the energy are h square over 2ml square, and the second one is h square at 2h square over 8ml, uh, not 8ml, because a16 and a4 square over 8 cancels out, so it's only this only. So and so we get m over ml square. So these are the possible energy outcomes. Now the, when we talk about the energy, expected energy, okay, when we talk about the average energy, value of energy, average, average, okay, energy. Now we both know what is the average energy. We all, sorry, you know who is both. Why they say both? So we all know average energy is nothing but the probability density, probability density, or probability values of the probability distributed to the equation, the wave function times times the expected energy values. N is mean we are talking about both. N is equals to 1, sorry, N is equals to 2 and N is equal to 4. Here this is what it means. So this is our average energy, and what I meant by probability density is these values over here. Okay, if we don't take the square, we will get the answer in negatives. So how do we do is this? So n equals to 2 and n equals to 4. uh, it's actually 3 by 5 square times, what was our n equal to 2 equation? This one over here, h square over 2ml square. This one over here is same, 4 over 5, so only the 4 is difference, times 2m, sorry, not 2m, 2h square over uh, ml square. Okay, so this is our the second equation. Now what happens is, actually, if I actually do this, it will be a long process, so I'll just give a summary like how it will be done. E of n is equals to, or not E of n, the probability, of course. The probability is the not the probability again. The energy, expected energy, or average, okay, which is 3 by 5 square, and sorry, h square over 2ml square plus 4 over 5 square over 2h square over ml square divided by, if I'm not sure about the 2, but this is how it should go. And what you should get in the end is 73 by 50 h square over 50, or so, not 50, 50 is written there, ml square. This is what you should get. Now we have found our expected value, plus we have found our the values of the two states and their average. Of course, since they have the same, like, average is what, 4 plus 8, 2 divided by 8, right? Divided by 2, which is 4 again. So this is one of the question, like one of the equations, one of the solving methods which we have. And I thought I would do more, like more than one, but since the only this one took like a lot of time, but we could have like we could look at this problem once more, because in these problems, even though they like don't seem tough, they have a lot inside it. So just for an overview, we have a particle of mass m, this symbol m, and it's in a box, a rigid box, and that box and the particle is can only move in one dimension. Its dimension is only this is the only dimension for which d stands for dimension. Okay, now then axis, the x-axis, this one. Okay, so then this is a wave function of the particle, like how, which wave function the superposition state is moving at, the superposition of it being in this, and this is changing, uh, so that means it's the energy level, right? So wait, I think I just understood what this actually is about. So we're talking about energy level. This is n1, this is, I mean, n2, or to be exact, this is n0, this is n2, and this is n4. Now at this point it's moving in this direction and this direction. This one as well, it's moving in this direction and this direction. In this one as well, it's moving in this direction and this direction. But the amount of energy they put in, the amount of energy they put in is, the energy put is different. Energy energy required, it's better, is like this, required is different. Okay, this is the main thing. So then after just now I don't know if it's correct or wrong, but this is how I interpret it as, or how I look at the question is, that we are talking about the oscillation of the particle in different levels, and different levels has different inertia, of course, which is the question as it says. And so this is the superposition for the particle. If the particle is in this state, for its probability prob of p in, sorry, in in and for is this over here. uh Wait, let me just make a bright one. This one is better. 4/5 squared, and of it being in, if it being in this one is n2 is equals to n2 square. Okay, which is, why is n2 square, which is 3/5 square. Okay, and yeah, that's it. Thank you.